So, I know that everyone here, or most everyone, has heard the stories about computers gaining intelligence and destroying the world, right? Well, quantum computers aren't like that, although they do have components like normal computers that's miles between them. So, they use things called qubits, or quantum bits, to record information. In a normal computer, these would be a little switch that can either be a 1 or a 0. But they are actually gigantic compared to a quantum bit because it is common to use a single electron as a switch in a qubit. So, since electrons respond to magnetic fields, you can angle an electron with a changing field. But the thing that sets quantum computers apart from any other piece of technology on the planet is that a qubit could be a 1, a 0, or both at the same time. Yes, you heard me right. That is a quantum object. And this is possible because of something called quantum superposition. I bet all of you are thinking, Clay, you're a nerd. And yes, you're exactly right. But you don't have to be a nerd to understand this. The best analogy of this is imagine some sand. It can be a cube, a sphere, or something in between, both a sphere and a cube. Of course, this would not be perfect, but it's the best idea. So, even with all of these amazing things that set quantum computers completely unique and amazingly completely away from any other piece of technology on the planet, I know I said that, but they would not have the singular amazing computing power that they do if they didn't do this. When a quantum computer makes a calculation, it will use some qubits to solve the equation. But instead of using 64 bits of data, or bits, to get 64 pieces of data, it will use only 6 qubits to solve that equation. The whole quantum computer maps the correlation between the qubits and uses that for the calculation. So, I know I can't be the only confused one here. This procedure is called something entanglement. Or better stated by Albert Einstein, spooky action. Entanglement is when two or more quantum objects, like these electrons, are linked so powerfully that they can remain connected, if not physically, from either end of the universe. Kind of like a quantum Romeo and Juliet, if you please. But I'm not even close to understanding the full ins and outs of quantum computing, but I can give you a good idea of how they work, and I can give you something to think about if I restrain myself to one language, English, preferably not nerdish. So what I'm trying to get at is that quantum computers are not a replacement for the usual boring 1-0 model. Qubits only have an advantage over the home team when trying to, say, factor a 500-digit number, which is supposed to be impossible for a normal computer. So if you're just trying to catch up on the latest video from your favorite YouTuber, it will probably actually go slower than a normal computer would. You know what? I don't quite understand any more of this. Get Einstein in here. He can probably tell you more. Thank you.